Sister Cook, we're going to start without Remington, and then we're going to have him, he's going to join in with us. So, everybody's got the quiz pulled up, and we're going to start it.
Okay.
Which of the following variables is /r categorical?
That's the toothpaste.
Yep.
Yep. A randomly selected brand of toothpaste at a convenience store.
I'm sorry, is this... Hang on. I think I'm in the wrong one.
Uh-oh.
I know. Okay,
Is
we're
that
doing the
bad?
quiz, right?
This is week 4, lesson 8 group meeting.
The quiz. Okay.
Okay, this one I actually had a question about. Is the 112, is that one the statistic?
Yeah.
Okay, that's what I thought. And then the other one's the parameter.
Yep. That's what I got.
So 100 is parameter and 112 is a statistic.
Yeah.
Can I look at all these answers when I'm done with my quiz?
After the close of the like when you no longer can take the quiz anymore, when the time ends, then you can go back in and see the answers.
Okay. That's fine.
Waltham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values, and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample would we collect to gauge the residents' responses to a proposed increase in property tax?
I can't. Hold on.
You wouldn't want to do a cluster sample because then you can get everybody in the high property value or everybody in the low property
Is it
value.
the stratified? I think I said stratified.
I said stratified.
Yeah,
Okay, stratified. Okay.
Yeah.
that's what I would say. When designed experiments are conducted in a public school system, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected classes. Which type of sampling scheme is implemented?
This one I was a little confused about, but I want to say it was the systematic. Did anybody else say systematic?
I was thinking cluster.
Cluster.
Well, remember how in the systematic, when she says you start out with something random, that's what confused me, was the 4th grade. Remember how, like, and I don't know, I'm just throwing this, I'm not saying cluster is wrong, but do you guys see what I'm saying, kind of?
I think, though, that they started, they choose a particular district and then but they don't use, like with systematic, is you have to start and then use every K, like every Kth item.
But
So
I thought you start with a random one and then you go every Kth.
yeah, but this one is starting with a random, but then it's not using every Kth. It's using all the students.
All the students.
Oh, okay.
And that's what makes it a cluster. Because with a cluster, you're taking all the items in one or more randomly selected cluster or block.
Oh, okay. Okay. That's cool, I see.
You randomly select it first, but then use all of the data within that cluster.
Okay, so in a cluster, you're going to do a random in the beginning, but then you just do all of it.
Yes.
Yep.
Okay, so that's basically the same as systematic, except you're using everything.
Yeah, and in systematic,
Okay.
select every Kth item in the population beginning at a random starting point. So you start random, and then you use every 8th person or every 12th person from there on out.
Okay, that makes sense.
Okay. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented?
Is that just an SRS?
That's what I got.
That's what I was thinking.
Yeah,
Okay.
a simple random sample. That works. A special interest group is conducting a survey regarding wolves in the Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took a list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented?
Is that stratified?
Stratified.
Stratified, yeah.
Yep.
Okay. A survey was taken of purchases at the crossroads. Open the data file.
Quickly, any questions about this sequence?
Oh yeah, this data file one. My computer wouldn't let me open that.
You have to have the
Oh,
needs
it's
to have some idea
SPSS.
what's
That's why.
They're not my Windows scrambled.
Okay. I'm gonna leave in like 30 minutes.
Are we taking a test? What's going on, guys? Sorry, I was a
Oh my
little late.
gosh, I could not hear what was going on. Yeah, sorry, we opened it without you. You can open
No, that's
it.
totally fine. I'm a little late.
Oh, well,
Round
we
number
opened it
9.
before you were even early.
Does anybody already have it pulled up, or do I need to pull it up?
Yeah,
I still need to download.
You're the
I
worst.
got it.
You've got it pulled up?
I'm just.
Yeah.
Sometimes he helped me.
So
You said my homework to here?
what I got for you
That's
is
actually why I sent it to you. So you can
771.
Oh, I did do it.
Will you send it to me?
Yeah, I sent it. Well, all the times I remember. Sometimes I'm so busy, I still send it to him.
Your hair is really smart. Ladies.
Still chasing ladies, man. That's not how you do it.
Chase.
Yeah, you don't chase them. You just be alpha male.
You're gonna see how they're gonna be following you like crazy.
Yeah, what's the homework? What day was it? Day 12?
So we're trying to open up a file to answer a question.
Yeah.
Okay.
Crossroads, purchase one.
Yeah, really, I'm 100. Starting at transcript. I can just move my stuff. There you go. That works. Okay, so starting at transcription.
Does anybody know how to do this? I haven't opened. Does anybody know how to do it with Excel?
Sorry. What are we still on 9?
Yeah.
Sorry, I
Yep.
had to pull something out of the oven. We got stratified random sample for the last one, right?
Yes.
Okay, I just want to make sure. Okay.
So does anybody know how to find the mean using Excel, or do I need to type it all in the calculator?
Yeah. What you do is you just highlight the boxes you want to find the mean of, and then you click the little function button, and then it asks you what equation you want to use. Or the little equation button at the top. I don't know how to explain it.
Oh.
Like there's the FX button.
Right.
Click that.
Everything I want. Function button. Function.
Or like the insert function, the little FX thing at the top.
Is it the like the E looking thing?
Mine's an FX.
FX. That's FX.
Where do we find all of the data again? All of those files?
So it's on, the one I found was from the homework, or the preparation part. And then, so I just opened up that page, and then I had to go down to find Crossroads purchases, and then it led me to Excel. If that makes sense.
So on this.
Is the mean on Excel, is it the average? Is that what it's called?
Yeah. Yeah.
Oh, okay, so you click on that little E thing and then you...
Mine's not an E. It's an F and an X. But
Oh,
Yeah,
okay.
I found that. So it's the average, right? So
yeah.
turns, see what happens. Wait, what? So I got 4.802.
I have 4.771.
Oh, that's awkward. Okay. Did you include the amount, like line 1? Or did you go from line 2 to 85?
I went from B2 to B86.
B86. Wait, what happened to my 86? Shoot, hang on.
Okay, so B2 to B86. You highlight them all. I
Yeah.
finally got my remote desktop to work. I don't know if it's him in Idaho, but so you highlight them all. You right click. No, not right click. No, highlight them
So
all.
what did you say you had? 4.7?
Yeah.
4.7?
4.771.
Oh dear. All right, hang on.
There. I'll do it again.
All right. Okay. So explain to me. You highlight all of them, and then what do you do?
Then you go to the equation button.
Where's the
Right.
button?
There's an FX button at the top of the page,
Okay. Yeah.
and then you click on average.
Okay, so I'm still getting 4.771.
Yes, that's what I have.
That's what you have? Okay.
Yep.
I guess I shouldn't say still. All right.
So where does it put the answer at?
So I have it put it at the bottom of the cells. Like it inserts it. I'm such a terrible explainer.
So
Okay.
the answer is 4.801667.
4.771.
Why didn't I get that?
So what I ended up
so-
doing was I just, where'd it go? I just highlighted all of them and did auto sum to figure out the total, and then divided it by 85 to find the mean.
Oh gosh.
Just to make it easier on myself because I couldn't figure out the other part.
So I highlight them all. I'm gonna have to go back into this lesson and reteach myself now that it's letting me pull it up. Okay, so the answer, the mean is
4.771.
okay. And then using the software, calculate the standard deviation of this data.
Yep. So then you do the same thing with the equation button. But I don't know how to, because all I do is I click in a cell, like I click on the cell underneath all of the data,
Mm-hmm.
and I click insert equation or insert function, and then I click on ST. I think it's what is it? The STD one, standard deviation.
STDEV.
Yes, that's what it is.
Wait, which one is it? Oh, it's S.
At the very bottom of the list.
STDEV. Yeah.
So 1.911 or 12.
Yes. 1.911. Yeah.
Yep.
Is it
No, it's
STDEVP or S?
STDEV.
Mine
So,
has
no,
an
it's one-
STDEV.P and an STDEV.S.
Yeah. No, she's fine. I'm just trying to get my kids close.
I
There's
don't
a
know.
bottle that she's working on. It's inside of her diaper, or inside of her let me see. The standard deviation was 1.912.
Yes.
Yes.
Oh, I think I've got it figured out. 1.912. All right, now how do you create a histogram from that?
So then what you do is you click on, you have to have this function in your Excel program. If you click on the data tab at the top, there's another tab inside that says data analysis.
Oh.
I'm sorry.
Which data tab is it?
At the top, there's like home, insert, page layout, formulas,
Right. Oh,
data.
now I have that FX thing.
At the very end, it says data analysis.
So the what if analysis?
It's data analysis. So now you
Oh.
put it in.
Data validation.
No, so you have to like insert. I googled it to try to figure out what it needed. You have to like have it on your computer. It's not automatically on it. Now I don't remember how I did that. To do that, you go to File and Options. And click Add-ins. And at the bottom it says Manage Excel Add-ins. Click that and say Go. Then it shows up with a little pop-up box and you click on Analysis Tool Pack. Click OK. And then you'll be able to click on Data Analysis.
Is it the analysis toolpack VBA or the plain
No.
analysis toolpack?
Just the plain old Analysis Tool Pack.
Where?
And then it will show the data analysis and you can do the histogram.
Where? Oh my gosh, I can't even find. You click on File on
Yep.
the Excel?
Yep, File. And then you go down to Options.
I can't even find my file. Wow. This is a special moment. Oh, wait. Oh, no. Does anybody else have a Mac that's using Excel? Because I cannot find File, and I'm not sure why.
Okay. So I did that, but I'm not seeing on the data toolbox where it is. Oh, I see it now.
Yeah.
And then you highlight everything.
I think you just click on the histogram and click OK. Yeah, and then you highlight what it needs. And then you click Chart Output at the very bottom. You click that checkbox and then you push OK.
Hey, it worked.
Yeah.
I think. I don't know if it's right, but it worked.
Hello?
Yeah.
Did we?
She's gone.
Oh, what the heck? Oh.
Is everybody here?
Yeah.
Yes.
What just happened? Oh my gosh. Everybody went silent and it like froze and nobody was there and then it closed and said that it wasn't working. Alright, my bad. Okay. So
That's
let's
bizarre.
get back to this. Yes, I created a histogram representing amounts spent in crossroad purchase. Next. Anybody else have anything or we can move on?
All good.
Alright. Miss Lemire and her research team measured the body temperatures of a sample of diving elephant seals. A thermometer was placed on a specific location on each seal to measure its body temperature. The body temperature of seals tends to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time that they initiated a dive and called this the representative temperature of the seal. The thermometers were placed in the hepatic sinus of 4 of the seals, and the seal's body temperature at the start of the dive was calculated to be blah, 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 blah. Complete the following table and answer questions 12 through 15 below. Okay. So,
I was a little confused on how to do this one, so.
Yep.
37.91 minus.
The mean.
Okay, so we gotta figure out the mean first of the. So 37.91 plus 37.25 plus 38.98 plus 38.16 divided by 4. So the mean is 38.075. Then we take 37.91 minus that and get.
You get A.
So you took the mean and you subtracted it from the number.
Yeah.
And that's the
That's
deviation.
negative 0.165.
I have negative 0.165, but I could have done it wrong.
That's what I got. Negative
Okay.
0.165.
I think it was
Okay, yeah.
1.165 because I did that once. Oh yeah, actually I did do that. Yeah, I got negative 0.165.
So
I forgot I did this one.
the next one is
So wait, it is negative?
Yeah.
Interesting, okay.
it's negative because it's negative away from the standard deviation.
Okay.
Oh,
So
okay.
you
not
find
from
the one, then you subtract that
from the
one.
Just left of the mean.
Yeah, sorry, it's left of the mean. So 37.25 minus 38.075.
Oh, I think I did this one. This is B.
Square root that.
I think I got 0.680625. Tell me if you get that.
37.25 minus 38.075. And then square root that. So 0.681.
Yeah, okay.
Wait, how did you get that? 37.25?
37.25 minus 38.075, and then square root that, and you get 0.681.
Yeah.
Oh, wait. Why did I do that?
So does X with the line over it mean that means the mean?
Yes.
Yeah.
Okay, that's weird. All right.
Okay. What is the quantity number squared deviations equal to?
Isn't it 1?
I have it as the variance,
Okay.
Of a variance?
but
I thought that was a different formula for the variance. Oh,
It's the
well, the variance is the value minus the mean squared times the probability, isn't it?
the variance is
Or
the
that's
the variance is the sum squared.
What?
The variance is the sum squared. The sum is you take all of the answers in the x minus the x with a line over it squared. You take all of those and add them together, and that equals your sum. And then you take that one and you square that, and that's how you get the sample variance, isn't it?
Yeah, that's what I'm talking about. I think, but that's not.
Yeah, because it's just saying take all those numbers and add them together. What is that? That's,
So I don't think it's none of these
right.
is correct, because the answer would be the sum. Isn't it?
Well, it's so this is what I'm thinking. The variance. So what I'm thinking, this isn't exactly the formula for the sum of it, but maybe that's just the variance, if that makes any sense. So the variance of the discrete random variable is the value minus the mean squared times the probability plus whatever other values minus the mean times the square, or times the squared times the probability. But if it's just the variance, is that just that section of that? If that makes any sense. Sorry if I'm confusing everybody.
I don't know.
Let's look it up.
Yeah, because I think what you have to do, okay, listen, y'all. So the second column, you have to take those and add them all up, and then in order to get the sample variance, you have to take that number and divide it by the number of variables minus 1.
Yeah.
That gives you variance.
So maybe
Wait.
there's
Divided by the number of variables. Yeah.
Yeah, so if you add up all of the numbers in the right column, take that number and divide it by 1, 2, 3, 4 minus 1. So divide it by 3. That would give you the sample variance. And I don't think that that's what they're asking.
so it's got to be none.
I think it's none of these is correct.
Okay.
What is the standard deviation of these temperatures?
I think I got it. Okay, so somebody else can try my work, but I think I got 0.619. And do you guys know how to get the standard deviation?
I got 0.715.
Okay. It's possible that I did my math wrong.
It's okay. How did you get that?
I did, so I took the mean and I subtracted it. Well, let's see. So all those numbers, I got the mean or whatever, and I subtracted it. So I got the negative 0.165, negative 0.825, 0.905, and 0.805. And then I squared that, and then I took the mean of those, and then I squared that.
Okay, because what I did was I found the variance, and then I squared the variance. And so I got 0.511, and then, 0.511, and then the square root of 0.511.
Okay, I don't know. I thought but this is how I was supposed to. I don't even remember like doing this.
No, yeah, I don't remember doing it either. I really looked at the book.
Yeah, I just looked up like standard deviation or whatever to do it. So is that how you do that? You find the variance?
Yeah, so you take the sum of the squared the
And
squared
that's when you
deviations.
do the x minus x squared plus
Yep.
probability.
You do x minus x squared. Add those all up. Divide them by 3 because it's how many you have minus 1,
Oh.
and I get 0.511 from that, and then I square root that.
I don't. Does anybody else have any input on how to do this? Yeah, okay.
If you have Excel, I mean, it's pretty easy, but probably got to do it by hand sometime.
At some point, maybe.
No one else does, but we will.
So, to calculate standard deviation, what I thought you do is you find the mean, and then you subtract the mean from each of the numbers, and then you square those numbers, and then you find the mean for those new numbers, and then you take the square root of that.
You don't exactly find the mean of the new numbers because you do one less than when you divide.
Wait, what?
You don't exactly find the mean of the new set because it has you take the total number minus 1. So it's when you divide.
Where did you find that?
In the textbook, there's the part.
Maybe
that
we should look at that.
it
I
has,
don't know.
like,
Maybe
the
yours
graph
is
of the
right
field.
then. Maybe we should just go with yours. Mine's a little sketchy.
Okay.
Wait, what did you say? My internet just sketched out.
Well, we don't really. Well, I think she's probably right.
What I did was I took the squared deviations, added them together, divided them by 3 because you take 4 minus 1, which I get 0.511, and then I take the square root of 0.511, and that gives you the standard deviation.
Yeah, that's how it is. So what would we get?
0.715.
Okay, so.
Under certain conditions, the standard deviation can be negative.
False.
False.
It would be true because when it's left of the mean. I looked it up in the textbook.
Wait, what did we put for number 15?
0.715.
Oh wait, so they're asking the number of the standard deviation can be negative or just the... Okay, that makes sense.
Wait, so are we
it
doing
can't
false
be
or true?
If it's left of the standard deviation, then it's technically a negative deviation.
Yep.
So true.
Wait, so it's true?
Yes.
Because the standard deviation can be negative. Oh.
When it's left as a mean.
Yeah, 16.
Alright, so 17. What location resulted in the most consistent temperature measurement from one seal to another? So the deviation is which deviation is the smallest? So it'd be the extradural.
Yep.
I can define standard deviation.
Stupid question.
Okay. The number of hours students spent studying for an exam were recorded. The data are represented in the box plot below. Use this box plot to answer question 19 and 20.
What was the third quartile? 8?
Yep.
What is the third quartile?
8.
That is 6, 8.
8.
I'm blind. What percentage of the data lies between 4 and 8 hours? That's going to be
50%.
50%.
Okay, wait. Going the last two questions. The third quartile is, I mean, the beginning of 50 to 75%, right? So you got 1 to 25%, 25 to 50%. So we're saying like at 50%.
Third quartile.
Between the first and third quartile is 50% of the data.
Your minimum is 2. Your first quartile is 4. Your median is 6. Your third quartile is 8, and your maximum is 12. So 25% of the data is between 2 and 4. 50% of the data is between 4 and 8, and another 25% is between 8 and 12. So the percentage of the data lying between 4 and 8 is 50% of the data.
Right. So on question 20, what percentage of the data lies between 4 hours and 8 hours? It looks like, numbers, that's all within one standard deviation, and isn't the rule like 68%? Like, is there a rule for that?
Well,
No.
the reason being is because on a box plot, where 4 is, that line is where your 25th percentile is. Where 8 is, that's your 75th percentile. And so from 4 to 6, that would be 25%, and between 6 and 8, that's another 25%.
Okay, I thought that was a standard deviation box.
No, that's the median. That's the...
To begin making mRNA.
What was that? Okay. An observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 ppm are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52. And values outside of this range are unusual. We will assume 1.59 ppm is the value of the mean minus 2 times the standard deviation, and the mean plus 2 times the standard deviation is equal to 2.522 or 2.52. It is reasonable to assume the measured nitrate concentration is normally distributed. Uses information to answer 21 and 22. Estimate the mean of the measured nitrate concentration in Rexburg's drinking water.
Okay, I'm like so confused what the mean is in this. I don't even know what values to use.
So what you do is you take m minus 2 times the standard deviation. You know that the m.
I take m.
The mean. I'm looking at. Look at the formula in the question. M minus 2 standard deviation and M standard deviation. So if you just take that right now, pretty much you're solving for the standard deviation. Or you're solving for the mean. I'm sorry.
Okay. So you plug in the standard deviation to that.
You do the.
Or do we have the standard deviation?
Nope.
Oh, never mind.
You have to do an algebra problem to get to it. It was kind of difficult.
Oh, okay. That makes sense why I was so confused. So you're going to plug in... What values do you plug in?
So what I did, because we didn't really learn this, I just kind of figured it's what you do because there's no other numbers given to you, was first I solved... I changed the problems so that we could solve for the mean on each side. So you'd have 1.59 plus 2 standard deviations equals the mean. And then also 2.52 minus 2 standard deviations equals the mean. And since you have that, I made those.
So you did like an absolute value problem?
I don't know what it's called. It's some algebra thing.
Okay.
I don't know any of this. It just kind of...
I know what you're talking about.
Yeah, so I took 1.59 plus 2 standard deviations equals 2.52 minus 2 standard deviations, and then I solved for the standard deviation symbol on each side. And I got yeah. So I basically got the standard deviation was 0.2325 and the mean 2.055. Because then I figured it worked because in problem 23 I had an answer for. So That's what my reasoning was.
Okay.
So
Yep.
I have no idea what you guys just did.
I know, I'm like so confused still.
Okay, so I made an equation. So I don't know how to do it with anything that we've learned in this course at all. So I had to take some basic algebra to figure it out, because there's no possible way to find out the mean without doing this, is what I thought. Unless you guys have another way of doing it. So what I have is 1.59 plus 2 standard deviations equals 2.52 minus 2 standard deviations. Then what you want to do is get rid of the standard deviations on each side.
Oh, I see.
So I subtracted the 2 standard deviations from each side and got 1.59 equals 2.52 minus 4 standard deviations. And then yes, go for it.
You're assuming that 1.5. You're plugging in the 1.59 and the 2.52 into the spot where the mean should be. Kind of.
Yes, sorta. No, I made.
Except you're doing plus and minus.
Yeah.
So that's all one equation.
Each other. Yeah.
Okay. So you subtracted the standard deviations and then you added the numbers to each other. And you just subtracted 2.52 from 1.59. Or the other way around.
Okay. So the very first thing that you have is 1.59 equals the mean minus 2 standard deviations.
If you want to try, you
So
can
what
try.
you want to do for that problem is you want to get the mean alone on the other side of the equation. So you add 2 standard deviations. So it makes it 1.59 plus 2 standard deviations equals the mean. So that's the first equation. The other one, you have 2.52.
Oh, you have two equations.
Yes, but you make them into one equation.
Okay, I think that's what I have is one equation. I wrote down what you said. What did you get for your answer? Did you get 0.93?
No.
Oh, okay, I did it wrong then.
You get 1.1718 and 2.055, right?
No.
So I have written down 1.59 plus 2 standard deviation equals 2.52 minus 2 standard deviation.
Yes.
So then I would subtract the standard deviation, and then I don't have any more standard deviation.
You would on the right side, you'd have...
Oh, I would have 4 standard deviations.
Yeah, you'd have negative 4 standard deviations.
Okay, I see why I did this wrong.
So then it'd be 1.59 equals 2.52 minus 4 standard deviations. And then what you do is you want to get the standard deviations alone. So you first subtract 2.52 from each side, which will give you negative 0.93 equals 4 standard deviations. And so then you just divide by negative 4 on each side. Yep. So it'd give you 0.2325 equals standard deviation. And I don't know if this is the right way of doing it, but it's the only thing that I could think of that made sense. And if you plug it into problem 23, you get an answer.
So that's the mean?
That would be the standard deviation.
Oh, that would be the standard deviation.
Yep. To find the mean, you plug that into the original equation.
Oh, now you just plug the standard deviation back in.
Yeah, so you can do like 1.59 equals mean minus 2 times 0.2325. And then you take that and add it to 1.59, and that gives you 2.055.
Okay. So you do the exact same thing.
Yeah.
Okay. Plugging the...
So your standard deviation
So I got
is...
for the mean. So for the mean, I got 2.055.
Yes, that's what I got.
Then you take that and plug it back into the formula.
No, that's your mean, and your standard deviation was the first number you got of 0.2325.
So what's the mean?
2.055.
2.055. Okay,
So-
I see.
Number 23 or 22 is 0.233.
Yes.
Oh, yeah, I forgot we have to round. So then for number 21, it's 2 point, how many do we round to? 2.01, is that right? Or do we round to 3?
You're into 3.
So it's,
2.055.
oh, because we can't, okay, I see. And then the other one is 2.233, okay.
0.33.
Between what measures? Oh. So then you just add 3 standard dev to the mean.
1 standard deviation.
Oh, sorry. My
Yeah.
things.
So it'd be
Which is
2.288.
Yep.
2.2.
So it's D then.
That's what I got.
Yeah.
Okay. What is the value of the mean of a normal standard distribution? The value of,
And so the mean never changes. So if we did the mean right, it's 2.055.
oh, for this question.
Yeah, that's what I think it is. It made no other sense. I don't know what else it was asking for.
That's weird. Oh, I guess, yeah, I think you're right, because this said use this information for questions 21 and 22, but it obviously is using this for 23 as well.
Exactly.
So what is the
Now
value
people
of
don't know how
the
to do
mean?
English.
What is the value of the mean of a normal standard distribution? So
0.055.
Wait, the value of the mean. Oh, okay, because the mean never changes.
Yep.
Okay. Value of a standard deviation.
So the answer for 21 and 22 are the same as 24 and 25?
I don't know about 25, because 25 changes with standard
No,
deviation.
25 is different. Oh,
Yeah, I don't know
wait.
what 25 is.
For a normal standard distribution? Let's find out.
I just resulted back to 1 because I had no idea. I couldn't find an answer.
They go over the sprinkled ashes in Hikers. That's illegal in California.
I have that for a normal, oh, you know what? I have written down, and I think I got this information on one of the reviews, that for standard normal distribution, that's what this is, the mean equals 0 and the standard deviation equals 1.
I would be totally fine with that. I had no idea. So it could be...
This is something that I don't want to like screw everybody up, but I'm pretty sure I got this off of one of the reviews. And that's why I have it written down.
I'd agree with it.
That makes sense.
Do we
Sorry, explain
want
it to me one more time.
So I just have written down on one of my study sheets that the standard normal distribution, the mean equals 0 and the standard deviation equals 1.
Okay.
I don't know why that is though. I have no idea. So I mean, do we want to go with that or?
I'd go with it because I had no other because it says it isn't supposed to go for that problem anyway, so I didn't know what other information you use.
I can look it up. I don't remember where I found it, but I can try to look it up.
For that to be part of that, because let me scroll down.
Standard normal distribution. We're allowed to use notes for this, aren't we?
One page, front
One-
page.
Or not for, I mean for this quiz we're doing right now.
Oh, yeah.
Okay, yeah, I just looked this up on Google. As discussed in the introductory section, normal distributions do not necessarily have the same means and standard deviations. A normal distribution with a mean of 0 and a standard deviation is called standard normal distribution.
It's also on, you guys, if you go to the individual preparation and you go to that review that they pull up and you go to lesson 5 recap, it says a standard normal distribution has a mean of 0 and a standard deviation of 1. Then it goes on to talk about the 68, 95, 99.7 rule.
Okay, yeah, so, yeah.
Makes sense.
So you're right, so it's 0 and 1.
Good catch.
All right, we're almost done.
Thanks.
The admissions committee for most Masters of Business Administration programs requires the GMAT as part of the application for new students. It has been shown that the scores on the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission to the MAACC program in the School of Accountancy at BYU is 500, but it is rare for students with scores less than 600 to be admitted. Uses information for the questions 26 through 31. So already we can write down, we know that the mean is 542.3 and the standard deviation is 120.54. So what is the probability that a randomly selected student will score above 542.3? So we have z-score equals...
Yeah, I was confused about this because how do you do that if the mean is the same as the value we're using? Because then it just equals 0, right?
Yeah.
Then you put the z-score of 0...
Oh.
And the probability would be 100?
Yeah, that's what I'm wondering. But that can't be right.
I got 50%.
Oh, yeah, 50%, because
Oh,
you're
that
not
would
going to
make
highlight
sense.
below it. It'll
Yeah.
be 50%. So
Oh,
0.
okay, so when you plug that into the applet, it gives you...
0.5.
Oh, okay, I
Yes.
see.
Well, the probability is 0.5, right?
Yep.
And what are
600.
we nearest 10? Okay, so just 0.5. Oh, okay, that makes sense.
40.
There's the probability that a randomly selected student will score below 600 on the GMAT.
68%?
Did you do the,
I have 0.684.
Yeah, 6.4, because then 3 decimal places.
Yeah.
You take 600 minus 542.3 divided by 120.54, and then you get, and then you take that z-score, you get a z-score of 0.479, put it into the probability applet, and then you get the highlight below it, and you get 0.68.
0.68. So you highlight everything below that point.
Yeah.
Okay. 0.68, 3 decimal places.
So then 0.316.
Yep.
The next one.
The next one, 0.316.
Yeah.
Oh. So you, for that one, you just highlighted 316. Okay. You just highlighted the upper region only?
Yep.
So then for the next one, you put the 10th percentile in, you get a z-score of 1.282, equals, you don't know x minus 542.3 all over 120.54. So then you solve for x.
Whoa, wait. What?
Right?
What
Am I
formula
right?
did you just do?
Yeah, I have 542.3 because you put it in. You get a z-score of negative 1.282.
So you put in the 0.1 in the area, right?
Yeah, so it's no. So in the you put that in the area. Sorry. Then you
Okay.
get your z-score.
And then when you get the z-score, what are we looking at? Only the middle section for that?
You're just looking at the bottom half because it's just the 10th percentile.
Oh.
So then you'll have a negative z-score when you put it into your equation.
So you got 0.999?
I have negative 1.282.
Oh. 0.1. Oh, 1.8282. Okay, I see.
Yep.
That's what I have. Okay.
When you
But this
times that
depends-
by 1, you're going to solve for.
Sorry.
So
You get x equals 387.767.
Yes, that's what I got.
wait, so what do you do with the z-score once you take it out?
So you put it into the equation.
Formula.
You put it into what formula?
So it will be you take the mean minus the z-score times.
What was the mean again? Okay, mean
Yeah, so it's 542.3.
minus z-score
Yeah, the z-score times standard deviation.
times the standard deviation. And that
you
gives
before you
me what?
you multiply before you subtract from 542.
So multiply the z-score by the standard deviation and subtract the mean.
Yeah, you'll subtract it from the mean.
Oh, okay. I'm subtracting that from the mean. Okay, I see. Okay. So what did we get for 29 then?
388.
0.380?
Did
Oh,
it say
388?
Yeah, you just round it to the nearest whole number, so it's just 388.
Okay, I see. Okie dokie.
So now my question is on the next question it asks for the 90th percentile. Do you use the same z-score, the negative 1.282?
Yes.
You keep that same z-score?
But yes, but instead of subtracting, instead of it being a negative z-score, it's a positive z-score.
You use the positive z-score.
Yeah.
Okay.
Oh, I see. Okay, yeah.
So instead of subtracting, you add.
Yeah, that's a short triangle. Yeah, the little one. Or like I can volunteer to talk to it.
Okay, I see.
And the long-term goals is like you could actually get your certified license.
Where's my calculator? So, what's our mean? It's like
100 or 700.
I got 697.
You got
so. Let me see. So you do 1.282 times what's the standard deviation?
120.54.
plus
So you take
542.3.
Wait, then are we
97, yeah.
Are we adding this or we're subtracting this? Aren't we?
You're adding it because it's a positive z-score instead of a negative z-score.
So I'm adding this to 542 plus, what was it, 154? Did you get 696?
Yes, but you round it to 697.
Okay, 697. So negative z-score means we're going to subtract. Positive z-score means we're going to add.
Yes.
Okay. Okay. Somebody. Oh.
Remington, are you still out? I just got your text message.
I'm here.
Jeremy. Oh, Jeremy. Okay, it's Jeremy. I'm sorry. Jeremy got kicked
Jeremy's
out.
Yeah.
Okay, so for the next one, you plug in 0.25 into the area, and you get.
Oh.
Right?
Yeah. Yep.
Yeah, that would make sense.
Then you get 0.674 as your z-score, right?
Yep, a negative.
So you,
Negative. That's
you
what I
do
did.
exactly what you did last time, except we do it with 0.25 and 0.75.
Yes.
Okay. And what did we get for those?
I
Did
have.
Jeremy make it back in? No?
No. I have 461 for 31 and 624 for 32.
461 and 621?
624.
461. Okay.
So 461?
Yep.
So you guys are using the normal probability applet and putting in just the quartiles in the area and then getting a z-score, and you're using the z-score. What's that step after that?
You're putting the z-score in that formula of the mean plus or minus the z-score times the standard deviation.
Okay.
Is that somebody's phone?
Yeah, sorry.
Oh, no, it's okay. I just want to make sure it wasn't Jeremy trying to message me and I'm missing it.
Is it 8:30 there right now?
Yep.
Okay.
Yep, you should go. Well, that was the last question. Oh, and it's not.
Yeah, I know. I thought it was too.
Marilyn, if you need to leave, you can just come back on and watch the video when I post it, and you can get the last ones, or somebody can text it.
I think I can be done at like 7:45 or 8:45. I just need to be there, I think.
So find the third quartiles is 75, so 0.75. You're going to use a positive z-score, right?
Yep.
0.674.
Yep.
Then do the same thing. 0.674. 120.4.
And equals 15.
Oh, 624.
Yep.
What is the mean distribution sample?
Consider a simple random sample of n equals 15 students taking the GMAT. What is the mean of the distribution of sample mean scores for all of the students?
What?
There's a lot of means in there.
So you take the formula, the standard deviation over the square root of n, right?
Is that it?
Well, that would be for the standard deviation. This is
Yeah.
So I think it's just 542.3.
542.3.
Yeah, just the regular mean.
Oh, because. Oh, yeah. I think you're right.
Okay. 542.3.
Deviation for all such samples. This one, I think we would have to do the standard deviation over
Yes.
the square root of the sample size.
Yeah.
Except we don't. Do we know what the sample size is?
15.
15.
Oh, right, I forgot. Which is we do what's the standard deviation?
120.54.
Wait, I got 31.
Yeah. I have 31.123.
31.1.
Oh, okay. So 31 point. Sorry, I just exited out of it. What was it? 31 point.
123.
1, 2, 3.
Okay. What are you guys talking about? So then 600 minus the mean, which right is 542.3 still.
Yeah.
But then the standard deviation is now 31.123, right?
Yes.
What is the probability that the sample mean for the GMAT score for an SRS 15 will be greater than 600? Is somebody having a party?
No, Remington's at the library.
Oh, holy cow, everybody is loud there.
Yeah, it's not really a library. Jeremy, are you back? Jeremy, are you back?
Will be greater than 600.
Hey, there you guys are.
So,
Sorry about that. I don't know what happened to my computer. Kind of just shut down.
that's the best.
Okay.
So,
What did I miss?
600
853
minus 542.3 divided by...
We'll have a score greater than 600, so it would be 0.3%. So 3%.
I have 0.032.
Yeah, but wouldn't it be 3%?
Yeah. Yeah.
Okay.
Oh.
We have to do decimal places. All right, sorry. So
That's okay.
0.0312.
0.031.
I have 0.032.
0.32. Yeah. Sorry.
0.032. Oh, 0.032.
Yeah.
Yeah.
Okay.
All right, y'all.
I'm wondering, I think I might be missing something.
Does anybody have any questions before we submit it? Jeremy, do you need some of these answers?
Yeah, I missed from like 29, 30 on.
Does somebody,
went down
can
for
somebody give me
28.
number 9?
Okay. So let's start from the beginning. Who has any questions from the beginning?
Nope.
Remington, do you need any of the first ones?
Well, I kind of went through them by myself. I'm not sure if ours are the same, though. We could go through really quick.
Okay.
So 1 true, 2 true. Are you there?
Yeah.
So 3B.
Yep.
4, is it B and C? I wasn't sure about that one.
Nope, it's A and B.
A and B?
A and B.
A and...
Apple
B as
and
in
dog.
dog.
Apple and
Oh, okay. So hundred's a parameter, 112 is a statistic.
Yeah.
Mm-hmm.
5D.
Yeah.
Mm-hmm.
6, A, B, C, D, E.
Yep.
7A.
Yeah.
8D.
Yeah.
Yep.
And then we're at 9 where I came in.
Okay. Where does anybody else need any help?
9. Where is my page? Number 9.
4.771.
0.771.
All right. Anybody else missing any answers?
Just 28, I think.
All right. 28. 28 is 0.316.
4.
So Megan, help me out with 29 through 35. That'd be great.
Okay. Do you know how to do them, or do you just need the answers?
I'm going to be working on these tonight to make sure I have it down. So just the answers for right now.
That's a stinky poop for you. Hold on a second, we're almost done.
Number 29 is 388. 388. Number 30 is 697.
Hey, if you hold on to her fast.
31 is 461. Number 32 is 624.
Jeremy, do you want to just screenshot my saved?
Jeremy, oh, am I not screen sharing? Here. I'll screen share.
Oh.
Yes. Jeremy, can you see it? Is it really small?
It's a little small.
Okay. What number do you need?
We're on 33.
33 is 542.3. 34 is 31.123.
0.13?
123.
0.23.
And 35 is 0.032.
Same thing.
Now, Jeremy, when you go back and do these, we were discussing this, though. How you do it is you've got to put the, oh wait, no, that's not this one. Which one was the one that we had to solve for it? Were you there for that question? Were we?
For it.
Oh, you were there during the 21 and 22, right?
Yes.
Okay, all right, so you were there for that. This one you just are plugging in like the 20% or the 25 percentile and the 75 percentile into that applet, and you get the Z-scores.
Okay. Right.
If you have any questions, you can text me. We want to submit it?
Yeah.
Yep.
All right, submitting. Yes. 97%. So which one did we miss? We missed, under certain situations, standard deviation can be negative, so it was false.
Oh,
Oh,
sorry.
it was false. Oh, no, you guys convinced me it was true. Okay.
Sorry.
It's all right. It's one question. At least I ain't done 97% in a while. The one we missed? Yeah. All right. You guys ready for this test?
More or less.
All right. So we want to meet on Thursday, same time?
Yep.
Yes.
Sure.
All right. See you guys on Thursday. Good luck on your test.
All right.
too.
Yeah,
Bye.
everyone.
Bye.
Thanks.